Okay, let's talk about numbers. So a rational number is any number that you can write in the form of a over b, where a and b are integers and b is not equal to 0, because you know if you divide by 0, it is not real. So a rational number in decimal form is either terminating decimal such as 5.45 or repeating decimal such as 4.1666. As you see, the 6 goes on and on, which you can also write as 0.41, and you put the dash over the repeating part, which is the 6. Each graph below shows a subset of rational numbers in our number line. So natural numbers are considered rational numbers because you can still write them in the form of a over b. You can write them as 1 over 1, 2 over 1, 3 over 1. Whole numbers are also considered rational numbers, so 0, 1, 2, 3. Negative numbers are also considered, so these are integers, so -2, -1, 0, 1, 2, and 3. An irrational number cannot be represented as a quotient of two integers. In decimal form, irrational numbers do not terminate or repeat. Here are some examples. So here we have 0.01, 001, 0001. So it's not the same. Each time it's different. And pi, as we all know, keeps going and going and going. Some square roots are rational numbers and some are irrational numbers. If a whole number is not perfect, its square root is irrational. So for example, rational square root of 4, we get 2. So that's one of the natural numbers, whole numbers, and rational numbers, and it's also an integer. Square root of 25 is also a rational number, whole number, and an integer. Irrational number will be square root of 3. So you see it's not repeating and it's different and it keeps going. Square root of 10 is also does not repeat, and it does not terminate. Rational numbers and irrational numbers form the set of real numbers. So all the rational numbers and irrational numbers together make up what we call real numbers. So let's talk about classifying real numbers. To which subset of real numbers does each number belong? So I'm going to use, I'm going to use this chart here to help me out. So 15, we know that it is, so it's part of the real numbers. It is a natural number. It is a whole number, and it is also an integer. Okay? For negative 1.4583, it doesn't have a dot, so that means that it stopped, so it's a rational number. But that's all it can be. It's not natural, it's not whole, and it's not an integer. The square root of 57, because it's not a perfect square root, it is irrational. So it's over here. It's irrational. So, it says to which subsets of real numbers do these three numbers belong? So square root of 9, which is 3, it's a real number. It's a rational number because, as you can see inside my little chart, all of these are rational numbers. It's an integer, it's a whole number, and it's a natural number. 3 over 10, it is a real number, and it's a rational number because I've written it in the form of a over b. It's not an integer, it's not a whole number, and it's not a natural number. Negative 0.45. Again, this number terminates. The dot is not there. So because it does not terminate, that means that it is a rational number. And then last but not least, square root of 12. Square root of 12 is not a perfect square, so that means that it's an irrational number. I hope this helps.